Okay, thank you very much to Baptiste to be here at our project seminar series. He will be giving a talk today on composing and causing space-time. Thank you very much, Baptiste, for being here, and I leave it to you.
Thank you very much for the invitation. Yes, what I'm going to talk about today is one of my central themes of research, which is a potential emergence of space and time as we find it in contemporary physics. I mainly come from the field of metaphysics, so I'm quite interested at metaphysical issues related to the nature of space and time in the context of quantum gravity. So this is what I'm going to talk about today. Indeed, according to a number of approaches in theoretical physics, space, time, and all space-time are not fundamental in a sense to be explained further. Rather, they exist by depending on another more fundamental non-spatiotemporal structure. And the prevalent opinion in the literature is that this dependence should not be analyzed in terms of composition. Space-time can't depend on non-spatiotemporal entities in virtue of having them as parts. But is that really right? That's the question I want to ask today. And the claim I will make is that, on the contrary, identifying emergence to composition promises to enhance our understanding of the physical situation. So there will be three parts of the presentation. I will start to set the stage by saying a few things about space and time. Then I will give a defense of the mereological view. So the view is that space-time could be composed from non-spatiotemporal entities. So it's based on a joint work with Sam Barron. That was just published a few weeks ago. And I will then make some more remarks about how to complement this account with an account of causation. All right, so let's say a few things about space and time in philosophy. So as most of you know very well, I guess, you have questions about the nature of space. Is it a substance, a set of relations? Is it a priori? Is it mind-independent? So you have this very famous debate between relationism and substantivalism. And of course, it's a debate about the categorical nature of space, but also about its modal relation with material objects. What's more fundamental? Is it possible for space to exist in absence of material objects and relations between those objects? For time, we have the same questions, but on top of that, we have questions about other specific features of time, namely the existence and origin of a direction or of a flow of time, if you believe that. So personally, I'm more a proponent of the block universe view, so I don't accept the existence of a flow. But that's the kind of questions people are interested in metaphysics of space and time, I guess. And of course, also in the philosophy of physics for people working on general relativity especially. And indeed, in the context of physics, the shift is no more, the focus is no longer on space and time, but rather on space-time as a unified four-dimensional manifold, which usually is taken to be more fundamental than space and time. The idea being that according to a quite straightforward interpretation of relativistic physics, which is sometimes called the geometrical interpretation, the easiest way to make sense of relativistic physics is to posit that what's really fundamental is a unified manifold, four-dimensional manifold. And special relativity, it's a flat Minkowski spacetime. In general relativity, it's a curved spacetime, which is supposed to have which is represented mathematically as having an intrinsic curvature. And then locally, you can have at any point in your relativistic spacetime, you can approximate your general relativistic spacetime with a special relativistic spacetime, which is which lives, so to speak, on on a tangent space at this point. But what's quite interesting there, I guess, already is that mathematically you will represent your space-time with two things. First, a differentiable manifold of points on the one hand, and then on the other hand with a metric. The idea being that you can first specify partial relations of order between points of your manifold, and then separately add on top of that a metric that will give you the distances in particular between the points. So it's already quite interesting to see that in physics you can represent mathematically a space-time by disconnecting the relations of ordering from the relations of distances. And that's something that will be interesting later for what I'm going to say. But before going back to space-time, I want to say a few more things about contemporary physics in general. An important distinction to keep in mind is the difference between empirically well-confirmed physics and some research programs aim at finding a novel and more efficient paradigm. So well-confirmed physics is mainly made of two mutually inconsistent mutually frameworks, or at least intention. General relativity on the one hand, which is taken to be our best theory of space-time, and so of space and time, and the standard model for particle physics, that which is based on quantum field theories, and that integrates special relativity, but not general relativity. And what's quite interesting is that general relativity describes gravitation, but not quantum effects, while the standard models describe quantum effects, but not gravitation. So we need another framework for some purposes. For instance, the paradigm cannot fully explain phenomena which are both gravitational and quantum. For instance, black holes, the earliest instance of the universe, or the nature of space and time. To fully understand those phenomena, we need to at least develop a kind of a story about how the two frameworks that are so different can work together to give a description of those things. So many physicists try to develop a novel quantum theory of gravity or a theory of quantum gravity in order to account for those phenomena. The two most popular approaches to do that, at least in number, when it comes to the number of physicists involved, are string theory and loop quantum gravity. But in fact, you find many different approaches that are different levels of development and that are interesting. And today we'll be talking about one of them, which is causal set theory. So it's not because those other theories are less known or at a less mature stage of development that are not promising. Actually, in this talk and in general, I have a kind of agnostic attitude about what's the right or the most promising research program. So the idea is more to look at different approaches and the possible metaphysical implications. Yes, so that's basically the kind of thing I'm interested at. And what's quite interesting, at least for a philosopher, for a metaphysician, is that in many of those approaches, space-time is said to emerge one way or another. So, of course, what it means exactly will depend on which of the research programs you look at. So here are a few examples quickly. It could be, for instance, the spatial distances or the temporal durations that you find in some interpretations of string theory, in causal set theory. I also listed Penrose's conformal cyclic cosmology here. Maybe it's a bit of a stretch, but happy to talk about that later if you want. The spatial and temporal ordering in loop quantum gravity. So there's the idea that sometimes the ordering between three events, the partial ordering between three events as described in general relativity, can be associated to three building blocks that correspond to the three events, and the relations of ordering won't be the same. So you can have some kind of deviation between the way things are ordered in the LQG description with respect to the general relativistic description. Another famous example is the number of dimensions. In string theory, it's quite well known that for reasons of mathematical consistency, you have to develop the theory by adding new dimensions. So the theories we have at the moment are either 10 or 11 dimensional, and it's expected that the final M theory would have to be 11 dimensional. So that's also an interesting question about how we should think about the four-dimensional space-time in relation to this 10-dimensional relativistic structure. So at first, one might think that, well, it just means that space-time has a different number of dimensions. But in fact, for some reasons I'm not going to talk about related to something called duality, it's not clear at all that's the right way to go. So it might well be that string theory also points the direction of a world where you don't really have a clear number of dimensions or something like that. But what I want to do today is not really to go into the details of those research programs. I want rather to focus on a philosophical question and ask what could this relation of emergence be, and what sort of ontological picture could follow from space-time emergence. How should we think of the relations between a non-spatiotemporal theory and all other theories describing entities located in space and time, right? So starting with general relativity, but of course also all the other theories. And of course, at the end of the day, we also want to relate that to our ordinary phenomenal experience of things being localized in space and time around us. So I guess in a way here, I'm focusing on space-time, assuming that when we get space-time, we have done the hard work to then explain our experience of space and time. Although of course there is some work to be done there. As I will mention later, another strategy will be to completely avoid trying to derive the existence of space-time and just try to relate our phenomenal experience directly to a non-spatiotemporal ontology. I'll come back to this later. But to try to put some order in this prima facie difficult issue, here I will be introducing classification I made in a paper I wrote to discuss the prospect of functionalism to help with this issue, to a classification of various issues one could have with the possible emergence of space-time. So first, there is a scientific issue, right? The one physicists are mainly interested at, that I call the scientific issue, which is to derive general relativity from quantum gravity with mathematical tools and bridge principles. And as general relativity is taken to be our best theory of space-time, it's a goal that physicists have in mind. They try to find to recover relativistic space-time as a kind of approximation or with other mathematical procedures from the more fundamental theory. So that's really a big part of the problem for physicists. Then you have a problem of empirical coherence that was discussed at length, both in the philosophy of quantum gravity, but also in the philosophy of quantum mechanics, in the philosophy of already in the philosophy of non-relativistic quantum mechanics. And very briefly, the problem is, how is it possible for a theory to undermine its own evidence? So say that a theory as there are evidence for the theory, and those evidence are measurements localized in space and time. So is there an issue to say that a theory which is empirically confirmed via measurements made in space and time is there any tension between a theory that says that space and time do not exist or space-time do not exist, if that's the case? So personally, I'm not that worried about this issue, and I think it has been kind of solved, and a lot of progress has been made to clarify why it was not such a big issue. But it has been quite central in shaping the way philosophers of physics think about possible issues of emergence of space and time in quantum gravity. In quantum mechanics, it was really about recovering local behaviors from an ontology where what's really the wave function living in a higher dimensional space. And a bit similarly in quantum gravity, the problem is how you're going to recover your localized objects from an ontology where you don't have space-time. So in quantum mechanics, it's only about space. In quantum gravity, it's the issue also propagate to time. Third, there is what I call the hard problem, by analogy with the hard problem of consciousness, as developed by David Chalmers. It seems that there is something a bit puzzling with the transition from the non-spatiotemporal to the spatiotemporal. Perhaps a kind of explanatory or conceptual gap between the spatiotemporal and non-spatiotemporal notions, or maybe here we should say between the temporal and spatial notions on the one hand, and the non-spatiotemporal notions on the other hand. Here again, I don't think there is a hard problem, or that at the end of the day that there is a hard problem. I think prima facie there is something really puzzling, and so it's worth formulating the issue to try to think a bit why we think that why we ordinarily think of space and time as being fundamental, and why we might be a bit reluctant to let that go. I mean, in many debates in metaphysics, space and time are taken to be fundamental. You can think, for instance, about David Armstrong defining physicalism as the view that everything is space-time, is a conjunction of space-time, and everything localized in space-time, for instance. So it seems that this idea that space and time must be fundamental plays a central role in a lot of the metaphysical debates nowadays. Or you could also think about human supervenience, that the world is a mosaic of things located in space and time, or space-time. So right, how are we going to rebuild our understanding of reality if space-time is not fundamental? And finally, there is the ontological problem, which is as follows. Is space-time real at all? And if so, how is it related to the non-spatiotemporal entities? How is it built from? Right. Likewise, if we want to take like a comparison with the philosophy of mind, just as our dualist or monist views, we could ask the same here. Should we be dualist and accept that we have both sorts of entities, or should we try to have a monist ontology? So why focus on those sorts of issues? Why am I interested by those issues? Well, as I said before, the literature focused mainly on the problem of empirical coherence, leaving aside more metaphysical disputes for sociological reasons, because the topic was first investigated by physicists and philosophers of physics. And it's kind of new to really try to use metaphysical tools in this debate. And I think it also has been for good reasons in some sense, because it was a way to address the difficulty by talking to both realists and instrumentalists who do not like much metaphysical disputes. So they try to formulate potential issues with this idea that space and time might fail to be fundamental without committing to a too realist view about the ontology of the world. However, the threat of empirical incoherence, in my view, is only one way to philosophically articulate the reasons of some scholars to believe that space-time must be fundamental. So I do think that the metaphysical issues should be dealt with too if one wants to convince people that space-time emergence is conceptually consistent. Some people might just, if you are not able to provide at least a rough description, a rough description of the ontology, of the underlying ontology of such scenarios, many people won't take it too seriously. So for all these reasons, I think it's quite interesting to do a bit of metaphysics of space-time emergence. Here I wanted to say that one way to go I won't be talking about today is space-time eliminativism, which is roughly the view that space-time does not exist at all, right? So we just have the ontology of the fundamental theory of quantum gravity, no space-time at all. And then your task will be to explain why we have the beliefs we have about ordinary objects being localized in space and time around us, but directly without the mediation, so to speak, of the relativistic space-time. So that would be one way to go, that I think is quite interesting. And if that's the right way to go, then general relativity will really just be an effective theory. And the relativistic space-time will just be a conceptual construction that we project on top of the non-spatiotemporal world, but it will not be really something over there in the world. If that's the right way to go, the only thing that exists would be the non-spatiotemporal structure to be described by a theory of quantum gravity. So in that case, we will have a kind of monist view of the kind I referred to before, because you will not have to double your ontology with an ontology of non-spatiotemporal entities at some level of description, plus another ontological level inhabited by spatiotemporal entities. So today, I will be assuming, on the contrary, the existence of the relativistic spacetime and ask about its relation to the fundamental quantum gravity structure, right? So as I said, it's not because I'm 100% convinced that that's the right way to go. I think at this stage there are many ways to go, and all of them are worth exploring. But today that won't be the one I will be talking about. So rather, I will be exploring the view that space-time exists by being composed of non-spatiotemporal entities. So it's a member of a broader class of view, according to which space-time exists, despite not being a basic posit of a theory of QG. And the emergence of space-time would just be the composition of space-time. Meaning a space-time region, for instance, would just be made of non-spatiotemporal elements, just as a table is made of particles. And of course, the just in this sentence is a bit question-begging, of course. And I quite like this way to go, this mereological proposal, because I think it helps dissipating a bit of the mystery surrounding the emergence of space-time, and it helps us to clarify a bit some complex situations that we find in some approaches to quantum gravity. There are other realist options, of course. You could use as a connecting relation between the fundamental non-spatiotemporal ontology and the derivative ontology, perhaps an identity relation. That would be nice, but of course it's quite difficult. You could think, for instance, of a primitive grounding relation, causal relation, or functional realization. Those accounts are not meant to be exclusive. For instance, perhaps if you think that composition can be a particular case of grounding, perhaps you can have both a mereological and a grounding picture. Or if you think of grounding as a relation of metaphysical causation, as Alastair Wilson, for instance, then perhaps you could think of the composition of space-time as a kind of metaphysical causation or something like that. So that's one possible role for causation in this idea of the emergence of space-time. But as we will see shortly, there is another possible role for causation I want to talk about. So Today, I'm not arguing that the account I'm providing is better than other accounts, but I just want to motivate it to make it more appealing that some people, again, some people who have they took for granted that composition was not the right way to go, and what we do in the paper and what I've been doing in a series of papers is to question this a bit. As an example, here is a quote from Vincent Lam and Christian Böttrich, who defend this view. So they write, from a metaphysical point of view, the functionalist perspective articulated in this article can be understood as a move away from the constitution or building blocks heuristics, according to which, in the case of quantum gravity, space-time and spatiotemporal entities are constituted by or made up from quantum gravitational building blocks. However valuable for physical and metaphysical theorizing in other contexts, these heuristics acts, when taken too seriously in the present context, as a source of conceptual worries concerning the constitution of space-time and spatiotemporal entities from non-spatiotemporal and hence qualitatively improper elements. Actually, Sam Barron, so my colleague with whom I wrote the paper that was just published in the Journal of Philosophy, articulated beforehand this dissatisfaction in an objection. So it's how the paper started its journey. Actually, it's I was at a conference in Australia that he organized, and I was engaging with the paper. And then we started discussing, and the paper is a result of our discussion about whether there is some prospect for using composition in this context. So it's why Sam plays two roles in this story, like providing the objection and also participating to providing the response to the argument. To see Sam's argument, let's say a bit more about composition. So as you may know, there are different layers of properties one may ascribe to composition. At the very core, you have what we could call a core mereology, which is very roughly a relation of partial order with a few definitions. And you think that if a domain of entities satisfies its definitions, in a way, you already have a kind of core mereology. But of course, it's very weak. So this basic mereological system doesn't conflict yet with the concept of non-spatiotemporal part. And so to get really a tension between the ordinary notion of composition and this idea of non-spatiotemporal part, you have to add further principles which are standardly associated with mereology. Just to give a precise description of this principle, it's good to just to have in mind the concept of exact location and weak location. So to go fast here, for instance, you take the object D here, it's exactly located at the region R4, right? But if you take the region R2, D is just weakly located R2 because it's not exactly located at R2. D is also weakly located at R5. So it's a weaker notion that it's a bit more liberal, a bit weaker to exact location. So one of the principle is the downward inheritance of location, which we usually accept as a principle qualifying parthood. Intuitively, that's just the idea that the parts of an object have to be localized at subregions of the region where the object is located. So, like location trickles down to the parts of localized objects. Another principle is the principle of harmony. The idea that for x and y, if x is a part of y, if and only if x location is a subregion of y's location, right? So here it's on harmony between the locations. Another principle is a smaller than principle. The idea that the proper part of an object has to be smaller than the object of which it's a part. And another principle is a compositionality of extension. The view that for any spatiotemporal object, y, I would just read the definition. For any spatiotemporal object y and for any x1, xn, if x1, xn compose y, then the spatiotemporal extent of y is a function of the spatiotemporal extensions of x1, xn and the spatiotemporal relations between x1, xn. So all those principles are usually ascribed to accepted for, at least for the mereology of material objects. But no, of course, none of the non-spatiotemporal parts have a location. So it will be difficult to reconcile this with the downward inheritance of location. It seems that there is a contradiction unless you are ready to accept that you can have another sort of location which is not essentially tied to the existence of space-time or ordinary space around us. So that will be one strategy, but in my view, it amounts to perhaps reintroducing another sorts of space. So we will end up perhaps with a two spaces approach. So I won't talk about this now. So let's accept that the downward principle of inheritance is false in this context of if we accept the relevance of the notion of non-spatiotemporal part. And of course, the three other principles also suppose that the parts must have spatiotemporal extensions. For instance, if you say that the parts of an object must be smaller than the whole they compose, to qualify them as being smaller, you need a notion of spatiotemporal extension, or at least of spatial extension. You need some kind of space. But we don't think that the four principles identifies a conceptual constraints on physical mereology, because actually there are two different traditions in the literature, and one is to take in mereology as being topic neutral. It constitutes a neutral framework for describing mereological relationships between, well, anything. And so one possible answer is that the four principles that some identifies are quite plausibly principles that are specific to only certain kinds of objects, namely spatiotemporal located objects. So if mereology truly is topic neutral, then those principles are unlikely to be essential features of mereological relations more generally. So here you have this idea that perhaps we should not keep fixed as a priori constraints what we take the properties of mereological relations to be, but rather let the natural science to constrain a bit what we are ready to accept or not as the logical properties of our fundamental relation. So the idea really is that any relation that obeys only these axioms can be used to consistently model a situation in which space-time has non-spatiotemporal parts. And the divide between the spatiotemporal and the non-spatiotemporal will then present no barrier to the application of core mereology, since core mereology is insensitive to such a distinction. So the idea will be that really the mereology of material objects will be a more specific case that add on top of core mereology further principles. But those further principles are not taken to be essentially linked to the partward relation. So I think we can draw a provisional conclusion here, which is that there is little reason to suppose that mereological models in which spacetime has non-spatial temporal parts are necessarily conceptually incoherent, right? So maybe it's not appealing, maybe it's not good for other reasons, but at least it's not a conceptual inconsistency. I'm sorry for the drilling noise outdoor. I hope it's not too problematic on your end. So a second thing I want to discuss now is, okay, if we admit it's not incoherent, is it good for the reason? So what's the point of identifying the dependence of spacetime to composition if this relation of composition is so weak, so weird, with not all of the logical properties we usually ascribe to the relation of composition? Right, so basically it's what I just said. Namely that it's a familiar style of dependence for physical objects, but the comparison with this familiar style of dependence seems to be lost. So the objection could be, one objection could be that, well, mereological models fail to shed any light on the dependence of space-time on non-spatial temporal objects, if that's really what's happening, that we have this core mereology at play here. So what I want to do now is kind of, so in the paper we say a bit more about conceptual reason for accepting it as being explanatory, but rather what I want to do is to go back to a particular approach in quantum gravity to show a bit how it may help to clarify the ontology we are dealing with in some approaches by helping ourselves with such a relation of composition. So let me say a few words about causal set theory. So very roughly, the idea is that the metric structure of spacetime, so the distances between spacetime points, can be recovered from its causal structure. So it's based on a theorem called the Malament theorem that shows this idea that up to a conformal factor, you can recover the global organization of a model of space-time model from an ontology where you just have a causal structure. And to say a bit more about the ontology, the idea is that at the most fundamental level, if this approach is on the right track, physical reality will be constituted by discrete causal sets, namely elements ordered by relation of causal precedence. Right, so basically, very often, such ontology are described with graph like this. So you have the nodes of the relations, and those relations are taken to be metric-free relations. So you can have an ordering between the relator of those relations without having distances between those points. And then you had some laws of nature. You have an evolution of this kind of the causal set, and so you have some kind of sequential growth. So you can picture this as a kind of like a grid that grow as more and more elements come into being. And as with many theories of quantum gravity, there are some results that suggest the derivability of some models of generativity from causal sets. Right, so the idea very roughly is that you will, so on the right you have a description in the relativistic description, right, from the point of view of generativity. So you have a region, and the idea is that you can find a mathematical mapping between this region as described by generativity and this ontology of discrete elements ordered by those primitive relations of causal precedence. And of course, as a philosopher, so physicists are more at the stage where they follow some intuitions, sometimes some kind of ontological intuitions, but they try to find mathematical derivations. And at the moment, it remains a bit unclear what the underlying ontology for this result and how we should make sense of how of the deep ontological nature of reality for this to work. So one question we can ask is a question I put there at the bottom: what's the metaphysics behind such mathematical derivations? So as I said, the fundamental structure described by causal set theory is not spatiotemporal in all respects because there are no distances between the fundamental elements. So it's something a bit something that has to be explained. And so one question one might ask is how to explain the existence of spacetime using the resource available in causal set theory. So to use the expression of Karen Bennett, right, it would be very helpful if we could specify a building relation that relates the causal set theory, the ontology of causal set theory to the ontology of the world around us, the space-time world. And so, of course, what I want to do is to say that composition can play this role. But before, maybe one reason why maybe we cannot, you might think, well, why not just use identity? The problem is that not all of the causal set structures can be mapped onto relativistic spacetime. So you can picture this as you can have some configurations, some sorts of causal networks that are not that don't have the right configuration to give rise to a spacetime. So one natural reaction would be to say, well, maybe it's just those are just mathematical pathologies, but so we don't need to worry about those models of causal set theory that do not correspond to spacetime. But the thing is that it's kind of expected that those sorts of spacetime-like, not spacetime-like causal sets might be needed to describe the high energy quantum domain. And this is something I found in the literature of physics, some comments in this sense. So it might suggest that the required building block cannot be identity, or at least some more, it will have to be a qualified identity, perhaps a token identity, something like that. But yeah. So the set theoretic membership relation is a natural candidate for this building relation in the framework of causal set theory itself, because as the name indicates, it's called causal set theory. So it was using set theoretic resources. But set theory is generally regarded as better suited to abstract entities. So viewing the core building relation of causal set theory instead as mereological might offer a promising alternative, given that traditionally, mereology is better suited to concrete entities. So it seems that maybe, I mean, at least we find that interesting. It might be interesting to recast causal set theory in mereological terms to give the theory new explanatory resources to explain the existence of spacetime. And I will try to go quickly since I'm running late a bit. The idea is that as new elements, so remember that the dynamics add new elements to the causal set. Well, we could add to the ontology of the theory fusions and say that, well, when new elements come into existence, new fusions come as well into existence, thereby generating new causal sums. So the idea is that the issue of space-time emergence becomes more tractable because the mereological interpretation of causal set theory turns the question of how space-time exists into a very familiar question. How is it that a whole might come to have causal properties different from those of its parts? So so in this case, how is it that the space-time whole come to have causal properties different from some of those of its causal set theoretic parts? Right, so here I go fast, but yeah, standard question as for a diamond can have causal properties that are not possessed by any of its molecular parts. They seem to arise because of the arrangement and the causal property of those parts that work together to produce an emergent causation. So if you identify the emergence of space-time composition, you can just intuitively use all the stories about emergent properties, weakly emergent properties, as they are analyzed by using a mereological ideology, so to speak. Right. So here I say that, okay, what matters is to recover a relativistic spacetime or something close enough. Okay, the label something close enough is something we have to say often to mention that we don't really need to exactly recover spacetime as it is described from the point of view of generativity, but we need to recover something that can do the same explanatory work in the domain of validity of generativity, where the theory is working extremely well. And now I want just to end this part of the talk by mentioning that, okay, there is no complete story here yet, but don't forget it's work in progress in physics itself already. So here, many gaps have to be filled by physics itself. But I think metaphysics can still be useful and interesting to at least provide a way of understanding how such a scenario might go and how it might be that space-time emerges from a non-spatial temporal ontology. Can I speak a bit more, or would you rather want me to stop now to have discussion? I have a last part. I can try to
actually
keep it short.
I think that I mean, if you can wrap up in like 7 minutes, something like that, it's fine.
Mm-hmm. Okay. I want just to say a few more things about causation in this context, because causal set theory refers to non-spatial temporal causation if we accept that it's not just a false name and there is really something causal going on in the fundamental network. But generativity explicitly refers to non-causal space-time relations between space-like separated events. Yeah, so as you may know, it's quite common in the framework of generativity to distinguish between 3 sorts of spatial-temporal relations. You have the time-like relations that connect events localized along a causal curve, which means that they can be connected by a physical signal propagating at a speed which is inferior to the speed of light. You have the null or light-like relations on the cones, and you have space-like relations. And space-like relations are relations between events or objects that cannot be related by any signals. So causation is used to define 3 different classes of space-time relations. So one might worry is that the first issue is that okay, sorry, I mixed myself trying to wrap up. So now okay, I will just do this. You have this separation between 3 sorts of relations: space-like, time-like, and null-like relations. And the separation relies on a theoretically more fundamental relation of causation, at least in the context of generativity. But if certain space-time relations exclude causation, how could those relations even exist, could space-time relations that exclude causal relations be composed from an ontology of elements related by causal relations? It seems that space-like separated events, in order to be causally related, will need signals propagating faster than the speed of light in vacuum, which is physically impossible. So those events are spatiotemporally related, but they cannot, as a matter of principle, be related by a physical signal of any kind. So it seems that there are no causal relations between such events, but those relations are taken to be parts of space-time. So how are we going to recover them from those? If you accept that reality is exhausted by a network of causal relations at the fundamental level. So there are two options. Either space-like relations do not exist. Space-time is really a set of time-like relations. And space-like relations are ideological surplus. So you really take your space-time to be made of different sorts of relations, and only some of them are really good ontological counterparts of what there is physically in the world. Or option two, you accept their existence, and you will have to propose a story of composition by absence. And so space-time will be partially composed by absence, in the sense that all the space-like relations will be composed by the set of elements and absence of causal connections, as given in the CST description. If one sees composition as a particular sort of grounding, then perhaps composition by absence is a kind of grounding by absence. So there is a bit of literature there. I don't have a particular view on this at the moment. But yes, I don't really know yet whether this idea is problematic or not. Maybe we can just concede that space-time can exist, even though only some of the relations that constitute it directly correspond to causal relations. But at least I see at least two options here. All right, so to conclude, identifying the dependence relation involved in the emergence of space-time to a relation of composition is coherent, at least if you accept this idea of a minimal notion of composition. Those mereological models are useful for explaining how it could be possible for space-time to be dependent on a non-spatial temporal structure. And that's useful because it helps a bit dissipating the mystery when people use this expression of emergence. And I also mentioned very quickly this idea of that it might help to give a more metaphysical interpretation of causal set theory. The idea being that non-spatial temporal causation can compose spatial temporal and perhaps even non-causal spatial temporal relations. And yeah, so it was quite dense. I'm very happy to unpack this a bit during the Q&A. Thanks a lot for listening to me.
So thank you very much, Baptiste, for your talk. So we have now plenty of time for Q&A. Is there somebody who wants to start? I see one raised hand. It's Yazan.
Should I stop sharing the slides, perhaps? Or what do you prefer?
Sorry, I have seen that Yazan has raised his hand. No, okay, so he didn't in the end.
No, I did.
Okay, so please, Yazan.
Yeah. Thank you, Baptiste. That was really interesting and informative. I have two questions, actually, if Sylvia will allow me. So the first question, I'm wondering whether the concept of emergence would be redundant in this framework of space-time composition. So if space-time is composed of non-spatiotemporal entities, then do we really need to still be saying that space-time emerges somehow? Because to me, it makes sense to say that an ordinary object is composed of particles without the need to say that it's emerging from them. Otherwise, emergent would always be, otherwise composition would always entail emergence, which might be a bit too extreme. That's the first question. So the second question is a bit more meta. So how would you, so I know that this type of theorization, let's call it naturalistic metaphysical theorization that attempts to find the, or to sketch the fundamental structure of reality. So how would you say, how would you respond to an objection that says that this this type of metaphysical theorization about the fundamental structure of the world cannot be, or is not possible without before arriving at a final theory of physics, which is basically the objection that was voiced by Karen Mackenzie in her chapter in the book you co-edited with Woodlick and Haggett. So that type of objection against the whole possibility of using in progress theories of physics to sketch a fundamental metaphysical theory. So yeah.
Right. Yeah. Thanks a lot. I mean, those are two great questions. Regarding the first question about emergence becoming a bit superfluous, yeah, I agree. I mean, actually, in one of my papers, I even try to defend that we should stop using the word emergence and talk instead about constitution. In another paper with Sam, we try to use the notion of dependence, the dependent spacetime instead of emergence. But the really important thing to keep in mind when you navigate this literature is that the word emergence is not used in the same sense in physics, and so in parts of the philosophy of physics and in other parts of philosophy. So in the context of the philosophy of quantum gravity, it's just a standard name that sticks the problem of the emergence of space-time. So it's more the problem of the name of a problem rather than the name of the right notion to be used to describe what's going on. And in fact, in physics, emergence at the beginning is a metaphor, right? So, and you have many different sorts of conceptual articulations of what emergence is. And you even find an account in physics, for instance, from Butterfield, where emergence and reduction are consistent, come together, while in other contexts, emergence will be defined as a failure of reduction. So emergence is a difficult notion. So very generally, I would be keen on continue to use it to interact with other people because it's a name that stayed. But I agree with you that if composition works, we don't need anymore really to a notion of emergence to play any explanatory work. So it's fine to talk about the composition of space-time. All right, that's for the first, yeah.
Sorry, can I just ask the name of the paper where you suggest that we should stop using the word emergence?
Yes, it's a paper in Disputatio called Space Emergence in Contemporary Physics from 2008. Yeah, and for the second question, yeah, so Kerry Mackenzie formulated this challenge against naturalistic metaphysics in general, saying, well, it's not clear that naturalist metaphysics can do better than a priori or analytic metaphysics, because on the one hand, we have a set of mutually inconsistent theories in physics, quantum mechanics on the one hand, or quantum field theories on the one hand, relativity on the other hand. So it's difficult to draw ontological insights. And if we start looking at quantum gravity, it's a set of highly speculative research programs. So how are we going to draw metaphysical insights from such a situation? So my position is that naturalistic metaphysics is the best we can do, but it has some limitations, of course. I think there are two ways to draw onto let's say there are different projects to infer metaphysical insights from the physics of quantum gravity. One is what I called a common core strategy. So you try to identify some kind of conceptual breakthrough that comes from one of the empirically confirmed theories, like say non-locality in quantum mechanics. So I'm convinced that non-locality is an empirical discovery. So there are some people pushing back a bit against this, like superdeterminists. But let's grant that you have some conceptual breakthroughs that we are happy to accept. And then it's interesting to look at how it will be embedded in the theories of quantum gravity. And so it seems that there will be something non-local in all of them. So if you find an invariant, namely some kind of ID that that pops up in all of the research program in quantum gravity, of course you cannot be 100% sure that that's something you should take for granted. But if this is to be found in our best physical theories, empirically confirmed, and if it appears in if it appears in all of the research programs in quantum gravity, then I think we have good reasons to take it for granted. But I'm happy to accept a fallibilist epistemology. And if I find an idea, for instance, the idea that some aspect of space and time have to go in almost all of the research program in quantum gravity, then I think we have a strong, we have a kind of knowledge. So that's one way to go, try to find something which is common to all of the programs. And the other way to go is to just look at one research program and really to be a bit more modest. I think that we are not really learning about the ontology of the world, but just about the ontology of the world if such a theory is correct. Like we are learning about the ontology of causal set theory, we are learning about the ontology of string theory, even though we don't know if it's true. So somewhere I wrote that conditional knowledge is knowledge still. Okay, it's not as good, but it might still be interesting, I think, to find that. And I think it's also Soazic-Le Bihan was this idea that you can have unlining you can have some you can gain some knowledge from understanding how false theories work. So yes, I guess there are three different ways to go. Either you consider you are not trying to understand the fundamental ontology of reality, but that's not my case. I want something more. And if you do that, you can either try to find some ideas, concepts, or whatever that are found to all or most of all the research programs in quantum gravity, or you can try to look at all of them and to try to understand what are the consequences of each of them. So maybe it's not a direct answer to Carrie's challenge when she because she wants something more. I think she has a more infallibilist epistemology in mind, right? How are we going to really learn about to know for sure about what the world is made of? But in my case, I always was a bit skeptic. So I'm happy to have to improve my the likeliness of something to be true, something like that. So yeah, I don't know if I was clear enough.
Yeah, that was good. Thank you.
Thanks for that.
Thank you. Do you have further questions, Alvaro? Yeah.
Yeah. Thank you, Baptiste. This was great. I have a question. You said that we should focus on these metaphysical questions in order to explain that this emergence is possible or coherent or something like that. But I was thinking that in other cases of interlevels relations and this kind of in science, people don't have, or at least scientists don't have these metaphysical worries. If people try to explain how the particle of a gas can describe the thermodynamic behavior of the gas, they don't worry about if the gas is real or if it's composed by the particles or if it's anything like that. Similarly, in the case of quantum mechanics, like in the emergence of the multiverse for the wave function. I'm thinking someone like David Wallace. They speak about how this is functionally realized, but they don't care as much as if about how these worlds exist or in which way, or if they are relativistic or if they are in a derivative level of existence. So I'm a bit worried about the motivation of putting the label of its mereological relationship, or if it's some other kind of relationship. So I don't know if you have something to say about that.
Yeah, I mean, I can talk a bit about. I mean, I worked a bit on the ontology of everything quantum mechanics, so I can say a bit about that. So I don't know if it's correct to say that people don't try to understand the ontology. I mean, for instance, I'm going to talk about David Wallace, for instance. David Wallace, in his famous book on the ontology of everything quantum mechanics. I mean, I don't know if it's probably not in the book, but somewhere else he confesses that he's not really into too metaphysical debates, but nonetheless, he still has a big part of the book is about how we are going to solve the proof basis problem, which is a problem about the fact that there is multiple ways to basically split the universal quantum state into substates that correspond to worlds. So it seems to entail that the number of worlds is not fixed. So there may be some kind of vagueness in the number of worlds, and also some kind of intrinsic vagueness to the worlds themselves. And it's puzzling. And I think that it's also where metaphysics comes handy. And David Wallace has a story to give about that, right? So he used first the notion of pattern from Dennett, and then he used functional realization. So in my terminology, I would say that he's suggesting a kind of building relation or connecting device between the levels, which is functional realization. And if you take, for instance, another example, Alastair Wilson, who defends another version of everything quantum mechanics, there he proposed to use instead primitive grounding as a connecting relation between the universal quantum state and the worlds composing the multiverse. So I guess I would resist a bit your assessment that that people in the philosophy of quantum mechanics and the Everettians are not engaging with us discussions. And actually, this day I'm working on a paper where I'm investigating how to make sense of the existence of worlds in Everettian quantum mechanics. And I think we can make progress by, I mean, maybe it's not possible to settle those issues, right? Because they are too metaphysical to be settled. But at the very least, I think it's helpful to clearly articulate the various ontological possible underpinnings for the physics. But yeah, maybe I was focusing too much on Everettian quantum mechanics.
No, but yeah, I have this feeling that maybe a scientist wouldn't care as much about if, for instance, if I'm speaking about how particles explain the behavior of a gas or behavior of an animal or something like that. I don't think they would worry much about if the gas is real or if the animal is formed by its organs or something like that. So this kind of heavier, yeah.
I guess you will focus on what I call the scientific problem, right? Finding the right mathematical derivations.
Right.
I mean, if you think about statistical mechanics, thermodynamics, it was an empirical discovery that thermodynamics could be derived from statistical mechanics and modulo some hypothesis. But I guess one objection you could make, and I think it may be the objection you are making, and I can see the pull of this objection, is to say that, well, in order to make progress, we don't necessarily need to be clear on the ontology. It's enough to have the right mathematical understanding. of what's going on, to find the right mathematical derivations between two different frameworks, and it's okay. And to this, I would say perhaps it depends, but I would still I would still advocate for generally trying to be clear on the ontological picture behind a particular theory that someone uses, because if you think about quantum mechanics, I think it was a bit a problem that a lot of I mean nowadays a lot of the physics of quantum mechanics is called foundations of quantum mechanics, because quantum mechanics has turned into a very practical field. So I guess that generally it's still healthy to try to understand the ontology of your theory and to be super clear about what's going on. Otherwise, you are at risk of missing good opportunities to discover new things. Yeah, it's how I will try to defend a bit my point of view, I guess.
Yeah, I totally agree that we should work in the foundations and to get a clear ontology of things. But when it comes about speaking out levels and how things compose and other stuff, like I get troubles like understanding like what does it even mean to say that a gas is something over and above its particles, or that space-time is real in a way that is not implied by whatever quantum stuff is there, or so I'm kind of always pull towards like immediatism or some kind of just derivative way of thinking about how things exist. But
yeah, fair enough.
Okay. Do we have time for more questions, Silvia? Okay. So yeah, speaking about elementalism, for instance, we were speaking about causal set theory. You were speaking about how like relativistic space-time relates to causal set, the causal set. But I was thinking that causal set theory is a clear example in which I would go for a elementalist way of thinking. Like I wouldn't say that the continuum space-time is real. It's just an approximation to the underlying thing. Just like I wouldn't say that if we describe a fluid by a continuum equation, it's not something real. It's because we know that it's just particles bouncing against each other. So I would say the same for causal set. So I wouldn't bother like going into all this mereological stuff for the example of the causal set.
Right. I mean, to be honest, I'm quite sympathetic to this idea that I mean, what we really need is to explain the predictive success of generativity. So if the physics of causal set theory is rich enough to give this explanation for why generativity was successful as a particular approximation, then it's okay. Of course, we don't need to recover more of it. And I mean, in a way, I mean, I have another paper where I voice what we call, again, another paper with Sambaran where we voice the idea of space-time quietism, in the sense that it doesn't really matter what we take space-time to be, and it doesn't really matter whether we manage to recover it. What really matters is to recover the practical physics, the measurements, the material things around us. So I think you're right. That's an appealing way to go, to just deny that space-time exists, and to say, well, no, we it's enough to directly relate practical, I mean, to relate what rods and clocks measure to the ontology of causal set theory. But it will work only if we will be able to understand why it's so efficient to organize all the information, all the systematic things we know about space-time in the form of a relativistic space-time, right? Because for now it seems incredibly successful in its domain of validity. So,
yeah, you're right. But I guess a causal set is just like really just making discrete the structure of space-time, and So I think it's not like such a radical move away. It's just
yes, but I mean maybe causal set theory is also an easy example to work with. I mean easier. It's easier because for philosophers it's more handy because we have kind of a rough understanding of the ontology of causal set theory, while for string theory, for instance, it's quite difficult to develop an ontological picture of the theory.
You're absolutely right. Yeah. I have a last question if we're still on time, or
actually, we are still on time. The only thing, Alvaro, would like to first ask whether there are other people that want to ask questions to our speaker. And if not, or not yet, then okay, so go ahead. Yeah, thanks.
So yeah, so when you were introducing the mereological relationships, you said that in order to avoid all these, that they are usually defined with making reference to a special relationship, like being apart, not apart, being close to or localized in some way, you're making them like a bit more abstract. And then
sorry, I didn't catch that. Could you repeat, please?
I think that when you were introducing mereological relationships, you said there is this problem because they're usually understood in terms of space-time relationships, and like something is in the same space region as other thing like that. So you were saying that something like it's something like more abstract than that, in order to avoid these kind of problems. But then when you were introducing causal sets, you said that the relationship between the causal sets and space-time, it couldn't be the set theory relationship because it was something just for abstract entities, something like that. And I feel like the distinction between the mereological relationship and the set part-whole relationship wasn't so clear for me. So what would make it different in case you're not relating it with space-time? And
right. I mean, I guess in a way, mereology is quite related to a nominalistic program, which is an attempt to try to get rid of abstract entities, because set theory has a commitment to the empty set, which fits doesn't fit well with an ontology of concrete entities. So many metaphysicians have tried to develop an alternative to set theory, which was not successful to my knowledge, but it's not really my area of expertise. But I think it's generally accepted that mereology is more concreteness friendly than set theory, because in mereology you don't have anything like an empty set or something like that. It's really a way to cut parts into concrete stuff. Even though, of course, you can deploy mereology and apply it to abstract entities as well. But you have this idea that you have less commitments to abstract entities with mereology. But then, of course, it depends what's your view on the existence of abstract entities. If in your ontology you accept the existence of abstract entities, perhaps you lose this this appeal for mereology instead of set theory. At least it was what I had in mind on this slide.
Okay. Yeah, but
sorry if I interrupt you, but for abstract entities, do you mean just set? So what do you mean by abstract entities specifically?
I mean, abstract entities as a general class, including mathematical entities, propositions.
Yeah, okay, but we know that.
Not concrete.
Yeah, we know that there are, mathematical objects that are clearly, fictional, let's say, when doing physics, and others that do not. So I'm just wondering, so under your definition of abstract entities, anything goes. So this is the question, basically.
I mean, I don't know. I mean, for instance, for me, relations can be concrete or properties can be concrete. So I still have a quite sharp divide between abstract and concrete entities. If you accept the existence of, I don't know, tensors or numbers or this kind of mathematical entities, and say that they are independent from the physical world. I mean, Platonism is a form of realism about abstract entities, right? I mean, I'm not sure I understand the worry or the objection.
Oh, well, it's just that so you mentioned numbers or tensors. So of course, so tensors are objects that do assume meaning within a certain theory, which is relativity, right? And numbers, of course, per se, at least in my view, cannot be thought as being real, right? The point is that you don't just mention mathematical entities when you talk about abstract entities. You also refer to propositions, for example. Is it right?
Yeah, I mean, in this case, I was just talking about sets, really.
Exactly, sets. So
yeah.
you meant sets in general. Okay.
Yes.
So
In this case, yeah.
Okay. So this was basically the clarification I needed in order to follow the full discourse. So,
yeah.
but apologies if I interrupted both you and Alvaro, but we have somebody who wants to ask a question. So Francisco, go ahead with that.
I'm just curious about you didn't talk about this. You introduced Woodward somewhere in your talk about intervention. I was thinking about what was the connection with interventionistic causation. Why you mentioned this author? Because you went over it, but you didn't actually talk about it.
Yeah. Yes. So it was just basically to. So the part of the talk I skipped was asking about what are the accounts of causation in general, consistent with such an ontology where, at the fundamental level, you have causal relations, but non-spatial temporal. Sorry, the fundamental ontology is both causal and non-spatial temporal, and it seems to put constraints on the way you are going to think about the nature of causation. And I take interventionism to be a good approach in this framework as developed by Woodward, because it's a way, so it's not exactly a metaphysics of causation. I mean, if you're familiar with it, you know that, I guess, but it's a way to show, to track, in a way, causal relations by interventions, and the interventions don't have to be practical. It can be what Woodward calls logical surgery. So you intervene on a variable in your network, and you see what happens in the rest of the network, and if there are changes, you can find causal relations. And I think this way to think of causation does not require at all to have space and time in the background. Unlike other approaches to causation, like the process theory, where you think of causation as an exchange between in two space and trajectories, you can have a concept of quantities that move from one to the other. So you assume from the start the existence of space-time, or if you take human supervenience, you think of causal relations as being determined by the distribution of entities in space with a certain pattern. So there too, it seems you need space and time. But for interventionism, there is no need to use space and time to find the causal relations, because even though you change the values, so the word change may suspect something a bit temporal in the background. In fact, those chains are more transpossible worlds relations, but time relations. So it's prima facie more easier to couple to causal set theory. So that was what I skipped. But to be sure, I'm not saying that there is no prospect for other series of causation, like the regularity theory or the process theory. Actually, it's my next research program will be a lot about exploring the nature of causation in such scenarios. But at least prima facie, I think interventionism is quite appealing.
Okay, that's what I was thinking about. Yeah, I mean, the approach is neutral about the underlying metaphysics. So in a way, I can see the idea that you can actually make it compatible with the other approaches. Okay, there's no conserved quantity, right? Necessary for it's not necessary conserved quantity and so on. So it's like a neutral approach. Yeah. Okay. That's actually what I was thinking about.
Yeah, and I mean, you could commit further to one of the traditional views, or not at all. I mean, you could just say that interventionism is just getting things right at the right level, and there is nothing more you could say. I mean, it's an open question, I would say. At least I'm talking in the context of non-spatial temporal ontologies.
Right. I mean, causal sets traditionally have already preferred structure, supposedly, of causal relations, right? You are discovering things that already have a structure, a causal structure predefined, right? That's at least in the classical implementation of causal sets, right? And you are just discovering through interventions, right? Okay. So yeah, there's already a yeah. So you're saying that, so it's neutral. Now I'm confused about why would be a friendly approach, and it's a friendly approach as much as it is for the other approaches, right? I mean, maybe because of the conserved quantity thing. I mean, I can see that. Yes, conserved, like the field Dow and so on and so forth. Yeah, I definitely can see that. It's not doesn't require conserved quantity, like passing from the nodes from a node to the other. Yeah.
I was perhaps a bit unclear. No, I mean, with the quants of quantities, the problem is rather that there are quants of quantities along space-time trajectories. So you have a reference to space-time. So the idea was just that interventionism is not explicitly referring to space and time, unlike, at least superficially, the quants of quantity account or the regularity approach.
Okay, sorry. Yeah, the surgical. Yeah, okay, good. Yeah, thanks.
Yazan?
I just want to ask if there's no one else. Okay. Okay. So Baptiste, I know that you didn't mention it in this talk, but you do talk about utilizing the mereological composition theory was suggested by Laurie Paul in a couple of her papers. So I was wondering, how can you make use of that within the composition of space-time that you're suggesting here? Because to me, there's a difference between saying a chair is composed of properties such as being brown and being sturdy, and space-time being composed of non-spatiotemporal entities. So because the properties, they're not spatiotemporal, but they're located in space-time nevertheless. So so here the mereological composition is still in space-time, even though it's not. So I don't know if you know what I mean. The analogy is not exactly clear to me. How can we use this program of Laurie Paul's logical parts to say that non-spatiotemporal bits are parts of space-time?
Right. So actually, it's also in the paper I mentioned before, Disputatio. There I discuss a bit the the views of Laurie-Paul and some moves that we have to do to apply the spirit of what she does in this context. So I mean, I don't know if I got it right, but my understanding of Laurie-Paul's view is that you said that the properties are still in space-time in Laurie-Paul's view. I guess I will not really, because something quite strange. I don't buy it, but in her view, at least that's the one she defended in the paper called Logical Parts, is that locations are themselves primitive properties that are proper parts of the bundles of relations that are identified to material objects. So how does this work? For instance, if I take my glasses, they have a shape, a color. They also have a location. They are on my head. In Laurie's view, those glasses is a bundle of properties, and among the properties that compose the objects, you have the location property, the property of being on my head or being here in space-time. She's dealing with locations in a primitive way. So it's not exactly true that for her in this paper, since locations are themselves logical parts, that objects are localized in space-time, rather in a way space is built from those primitive locations. I don't know if it makes a huge difference, but at least it shows a bit that it's more radical than the way you may have make it sound Laurie's view, because it's not only that you can use logical mereology in a background space. Now, really, space is also built from the components. And so what I said then in the paper is that we can be even more liberal about logical mereology. So she calls it logical mereology, but just to be sure, there is no commitment to abstract or something. This logical mereology, we should think of it as being highly concrete, because it's a relation that structures material objects, according to her. So let's assume properties, relations, all of that is concrete, and we are talking about the building blocks of reality around us. So she already has this idea that an object can have as proper parts entities that do not belong to the same ontological category, because those proper parts are not themselves objects. They are properties. So you can have properties that compose objects. So with that theory that this logical mereology is trans-categorial, you can relate entities belonging to different categories. So what I try to say is that we can push this even further and say, well, you can have different sorts of logical composition from different sorts of entities belonging to different ontological categories. So for instance, you might think of a space-time region as being kind of objects, but being composed of, I don't know, causal relations, as described by a causal network, for instance. But yeah, I don't know if perhaps you want to reply to that.
Because I read the paper Logical Parts a long time ago, so I kind of missed the bit where she says that having a location is a property. But to me, there's still, okay, this moves the problem a little bit. So instead of properties being located in space-time, we still need, because I don't, correct me if I'm wrong, but I don't see how we can have properties that are not accompanied by a property of having a location within the bundle. So every object would be composed of a bundle of properties where one property would have to be the property of being located at space-time location. So if we so I know, okay, so I know you want to take the spirit of trans-categorical composition, but to me, I'm still not seeing how would that work without there being a property of being located within the bundle of space-time. Like space-time is an object and it has properties as component, as parts, and one of these properties seems to be that should be the property of being located.
Yeah, I'm still working on understanding exactly what you have in mind. But so you say that locations must be a fundamental ingredient or something like that, and it's I mean the way I think, I mean, unlike Laurie, I don't want to treat locations as primitive properties that enter into that is an input of the composing relation. I'm just happy to take, I don't know if you take the causal set theory example, you have all the causal relations, you have all the relator, so you can basically draw a list of which point is related. If you think of the diagram, you can make a list of each point or relator of a relation and see which is related to which relator, right? So you can basically emulate a kind of location, even though it's not the location of the derivative spacetime, but the system of locations is kind of other fundamental sort of location, which is relative to the causal network itself. It will not. It's completely at odds with thinking of location as a primitive property. It's more like you have the global organization of your fundamental structure. Yeah, I mean, could you help me here if I'm misunderstanding?
I think so. So basically, you're saying that it's possible that we have two different mereological composition schemes. One that Laurie Paul uses to account for ordinary objects, and one that you slightly modify to account for space-time by letting go of the location.
Right. I mean, to be honest, I don't buy into Laurie's views about natural object. It's more like I find inspiration in it. That it's kind of a very nice intellectual move, I think, to kind of free composition to its kind of spatiotemporalist natural interpretation. I mean, she wasn't exactly the first. I think it's some people working on the formal logics of mereology would say that, formally speaking, there is nothing that require mereology to be about natural objects there. But still, I think she had a very nice insight about how the world could be structured with something that is very akin to the ordinary composition, but that would cut very differently. And I thought that it was a very nice starting point to try to find a primitive notion to apply to the context of quantum gravity. I mean, in one of her papers, she mentioned quantum gravity, but she was mostly focusing on quantum mechanics and metaphysical disputes in the papers. So yes, it's more like I don't necessarily want to accept that the way I'm using her ideas at a fundamental level correspond to one thing I have in my ontology, and the way she's using composition to deal with more metaphysical dispute correspond to another sort of composition that is also in my ontology. It's more like I thought it was a nice concept, and I tried to modify it a bit to put it to work in a different way. So I'm not at all accepting this idea of primitive locations. So it's quite different from the view she had in mind, even though it was a very nice way to think about the Trupp versus universals debate. So it was quite awesome in my view.
Yeah, thank you.
I don't know whether Francisco has his hands raised from before, if he wants to ask questions. I actually before asked you, Baptiste, a question that was more like a clarification, but of course it was meant to explore, exactly the way in which you are presenting, in a sense, causal set theory, because that's the point, I think. But I would like to ask you whether you considered other approaches to quantum gravity, such as GFT, for example. What's your position, for example, with respect to GFT, and how would you reconcile your view with such an approach, for example, or whether you plan to work on it in the future?
Yeah, you mean group field theory, right? GFT, you said, right? I mean, it's not the one I'm the most familiar with, but I agree it's spectacularly radical in a way, and perhaps it's. I mean, my prima facie intuition is that it would be perhaps difficult to apply the kind of view I developed today to this particular case, because it's difficult to understand whether the question I have is whether GFT is consistent with a kind of anti-realism about abstract entities. It seems that in this program, it's almost like you have a kind of Pythagorean view where the world is made of mathematical structures. So I'm unclear if it's possible, and if so, how to translate this in physical structures. And if that's possible, how to use composition there. Perhaps possible, but yeah, no, I haven't worked in enough details on this approach. I don't know. I mean, if you have some ideas there, I'm happy to hear more about it. But
I think that it will be, on the one hand, challenging, on the other hand, very stimulating, because
yes.
on the one hand, one can say, well, but what counts in GFT is the near field approximation. So in a sense, it's impossible to apply your view to that approach, but it's not entirely the case once we stick to the abstract entities, as you call them. Like the tetrahedra, for example, that are taken into account in the theory. So I still think that, it was a curiosity, I just wanted to ask you whether you were planning to work in it, whether you were, already in the process, for example, of publishing something, whether you don't think that it's interesting at all. That's it. I mean, it was just.
Oh, no, it's super interesting. Actually, I read. I mean, my understanding of this is mostly with discussions and reading Daniele Oriti and Nick Huggett. So I have a rough idea a bit about what's going on, but it's quite challenging to understand. So it's also a lot of investment to. I mean, for each approach is a lot of investment to manage to get a rough understanding of what's going on. So for GFT, it's on my. I really want to learn more about it and to work on it. But for now, it's just I understood a few things about some ontological constraints, let's say, that you have there. But yeah, to me, it seems like perhaps the most challenging way for a metaphysician to make sense of the situation. So maybe it's why I didn't make progress on that respect yet.
I think that we are all on the same boat. I mean, when working on this stuff, there must be a hidden principle of solidarity among us. Working on different approaches in quantum gravity. So, well, no, thank you. You answered actually to my question, and I really hope in the future that we will have the chance to meet in person and to discuss in person about this.
I love that.
Are there other remarks from other people? No? Okay, so we thank our speaker again. Thank you, Baptiste. Thank you very much for your talk.
And thank you for your patience, for your great questions as well.
And actually, I really hope to see you all again. Our next meeting won't be on the 1st of June. It will be rescheduled for the 8th of June. Tim Maudlin will give a talk at 5 p.m. On the Zoom channel. And of course, all of you that are interested in participating are welcome to register, and we'll see you again very soon. Thank you. Thank you, Baptiste. Thank you very much.
Thank you.
All of you.
Bye, everyone.
Bye-bye. Bye.